Here this question is asking a 19 voltage battery is connected across a 250 ohm resistor. A part is asking how much current passes through the resistor. B part how much power is dissipated by the resistor, and C part how much power is delivered by the battery. Okay, now let's go ahead and find one by one, but let's draw the diagram first. First, I'm having a voltage that is 9 voltage here, and then we have a resistor that is 250 ohm. This is 9 voltage and this one is 250 ohm. The first question is asking us to find out the current passes through the resistor. What is the relation between resistor, voltage and current? There's an equation given to us, that is V is equal to IR. This is from the Ohm's law. Now using this we can find out the current. We have to just rearrange this equation. I is equal to V over R. V is 9 voltage and R is 250 ohm. And if you calculate, the current is going to be 0.036 ampere, and you can express this one in milliampere as well, that is 36 milliampere. Okay, so now we have find out the current. That's A part. Now let's look at the B part. B part is asking us to find out how much power is dissipated by the resistor. So you have to find you have to have an equation that is related to resistor and power, and from we know that power is given by I square R. If you watch my previous video, you know we derived two equations for the power. One is I square R, and yeah, I square R, that's the one required for this, so let's keep that one here. P is equal to VI, and from that one we derive these things, like instead of V we can put IR using the Ohm's law. Then instead of I you can also put V over R. You can write it in multiple different way, but here we only need this one because we want the equation that's related to power and resistor. So here we have that one. I square, make sure you put the ampere because we cannot plug if you put milliampere that's okay, but you have to put 10 to the power minus 3, but we don't want that. I put this one directly, 0.036 square, and then resistor, that is 250. 250 ohm. Okay, and if you calculate this one, that's gonna give you, okay, this is I square times R. Okay, we have 0.36 square and then multiply by 250, and if I calculate, that's 0.324 watts. That's the answer I'm getting. Okay, now we have done with the B part. Now let's look at the C part. How much power is delivered by the battery? The battery, when they represent battery, we need to have an equation with voltage. So that's another equation that is connected with power and voltage, is P is equal to VI. So we can use that one here. C part, V is equal to V times I, and we know the voltage is 9 voltage and the current is 0.36 ampere. 0.36 ampere, and if you multiply again you get the same answer, that is 0.324 watts. Okay, now we have done this problem. Now let's look at another problem. Here this question is asking a 12 voltage battery is connected to a light bulb and draws 150 milliampere of current. A part is asking what is the electrical resistance of the light bulb. B part is asking how much power does it consume. C part is asking how much will it cost to operate this bulb for a month if the cost of electricity is $0.11 per kilowatts per hour. Kilowatts hour. Now let's look at the A part. You can draw a diagram if you want. Okay, let's put a bulb here, and then we have voltage. They didn't mention anything about the resistance, so we don't need that. Okay, so this is our diagram. Now let's look at the question. what is the electrical resistance of the light bulb. So they are asking for the R. What are the things that's provided? We have voltage provided, that is 12 voltage, and we have the current provided, that is 150 milliampere. Now what is the equation that is connected with voltage, current and resistance? That is Ohm's law, that is V is equal to IR. We can use that one here. V is equal to IR, and since we are interested in R, we have to rearrange this equation. That's going to be R is equal to V divided by I, and V is 12 voltage, and then I 150 for milli, I put 10 to the power of minus 3, and then ampere. Okay, and if you divide and solve for this one, you're gonna get 80 ohm. 80 ohm for the ampere. Okay, so instead of 150 times 10 to the power of minus 3, you can also put like 0.15 is same, because 10 to the power of minus 3 means dividing by 1000. If you divide 150 by 1000, that's 0.15. So you can do it that way as well. You will get 80. So that is answer for the A part. Let's look at the B part. B part is asking how much power does it consume. So we have resistance, we have voltage, and we have a current. Now we can apply this equation like P is equal to V times I. P is equal to V times I. That is voltage is 12 voltage, and we have current, that's 150 milliampere. So 150 times 10 to the power of minus 3, or you can put 0.15, whichever you prefer. So 10 to the power of minus 3, and that's gonna give us 1.8 watts. Okay, now we have calculated the power. The next thing is they're asking, okay, let me use a different color. Okay, the next question is asking how much power does it, okay, that's B part. How much will it cost to operate this bulb for a month if the cost of electricity is $0.11 per kilowatts hour? Okay, so they are asking for the dollar, how much will it cost to operate this for a month. If it costs, the cost of the electricity is $0.1 per kilowatts hour. Okay, so first we know the watts. Let's write that one down. That is 1.8 watts. Now we want to cancel these watts. Okay, we want to cancel this one, and we want to bring it into kilowatts. So kilo means 1000, so we can say okay, 1 kilowatts is 1000 watts. Let me write that one right here, 1000 watts. So what I'm going to do is I'm going to convert this given watts into kilowatts. To convert into kilowatts, I have to have this watts in the denominator, so watts cancels, and I have to have the kilowatts in the numerator, kilowatts here. Okay, put that 1000, copy this one, write exactly like this, 1 kilowatts 1000, and now we have converted this watts into kilowatts. Now the next thing is we have to know the time, because hour, kilowatts hour. They are saying how much will it cost to operate this bulb for a month. Okay, so we have to know how many hours in a month. Month is average 30 days, right? So we have to put 30 days, and 30 days in a month. Okay, so 1 month is equal to 30 days. Now I want to have the answer in 30 days. So I put the 30 days first. So let's put 1 month here. 1 month, and put one below this, and then to convert month into day, you had to have the month in the denominator. So I put 1 month here, and then 30 days. Because first you have to convert in days, then we can convert that one into hour. Now 1 day contains how many hours? 1 day contains 24 hours. So multiplication, okay, these are multiplication, okay, don't mistake this. Okay, so 1 day contains 24 hours. I have to cancel this day, and I have to have the answer in 24 hours, so I put the hours in the numerator and then days in the denominator. So 1 day contains 24 hours. Okay, so that's a multiplication. And the next thing is, now we have converted this day into hour. So we have everything now. We have converted watt into kilowatt and the month into hour. So we have the kilowatt hour. The final thing is we have to multiply by the price. So it cost 0.11 per kilohertz hour. So 0.11 per kilowatts hour. So here kilowatts hour in the denominator and the dollar in the numerator, because the final answer we had to have in the dollar and kilowatts hour has to be cancelled. So that's why we have the kilowatts hour in the denominator and the dollar in the numerator. And if you multiply everything and solve for this one, you're going to get $0.14. And that's our final answer. I hope you guys find this video helpful. Don't forget to subscribe my channel. See you guys on my next video.